So, hello student. In the last class, we have discussed about properties of triangle, some important formulas, and their important questions. Now, in that class, I will discuss all the important question that comes in your previous year of that chapter. Okay. Now, the first question is of properties of triangle is in a triangle ABC. In a triangle ABC, show that show that b cos square c by 2 b cos square c by 2 plus c cos square b by 2 is equal to s. The solution of that was b times of cos square c by 2 plus c cos square b by 2. Now the value of cos square c by 2 is under root s upon s minus c by ab. The value of cos will be s c by 2 is s minus c upon ab whole square plus c times of the value of cos b by 2 is under root s minus b upon ac whole square. Now the value will become b times of s minus c upon ab plus c times of s minus b upon ac. Now c will be cancelled, b will be cancelled. Okay, so you will get s of s minus c by a plus s of s minus b by a. So if you take a common, so you will get a and s common. So you will get s minus c plus s minus b. Okay. So the value will become 2s minus b minus c. And the value of 2s is a plus b plus c. So s upon a plus b plus c minus b minus c minus and c will be cancelled. So s upon a times of a, you will get the value s. Okay. Now the next question is if cot a by 2 comma cot b by 2 comma cot c by 2 are in AP, then prove that a comma b comma c are in AP. Now see the solution of it is cot a by 2 comma cot b by 2 comma cot c by 2. So what is the value of cot a by 2? S minus a by uh, delta, and cot b by 2 is s minus b by delta, and cot c by 2 is s minus c by delta. Okay. So all under root will be removed. So under root cancelled by under root. So delta will be cancelled by delta. S will be cancelled by S. So S minus A, comma S minus B, comma S minus C. Now, if S minus A, S minus B, S minus C are in AP, are in B, because chord A, chord B, chord A by 2, chord B by 2, chord C by 2 are in AP. So that was also in AP, their values also in AP. So S minus A, we get S minus A, S minus B, S minus C are in AP. Now, if I say, we know that if we subtract same thing from AP, so that result will also in AP. So if I subtract S from all terms, so minus A, comma minus B, comma minus C are in AP. And we also know that if we multiply or divide anything, sorry, if we multiply, add, multiply, add, divide, subtract from AB, so we will get the AB will, value of AB will be same. So if I multiply with minus 1, then A comma B comma C are also in AP. So this is the proof of that question. Now next is, prove that cot A by 2, cot B by 2 plus cot C by 2 is equal to S square upon delta. Now the next question is, prove that cot A by 2 plus cot B by 2 plus cot C by 2 is equal to S square upon delta. The solution of that question is, the value of cot A by 2 is S minus A by 2, S minus A by delta, plus the value of cot B by 2 is S minus B upon delta, plus value of S minus C upon delta. Now just a wait, huh? 1 minute. So student, generally in that question was printed wrong. Here will be only cos B cos C by 2 plus C cos B by 2. Okay. So you will get answer B cos C by 2 plus C cos B by 2. That was your question, okay? Not square. Now coming the last part, S minus A upon delta plus S minus B upon delta plus S minus C upon delta. That was its LHS. So if I take S upon delta common, so what I get from first part, I will get value S minus A. From second part, I will get value S minus B. From third part, I will get value S minus C. Now, if you added all three, then you will get S upon delta as 3S minus of A plus B plus C. And we know that S parameter S is equal to A plus B plus C by 2, and the value of 2s is equal to a plus b plus c, which is equal to the perimeter. So a plus b plus c is equal to 2s. So s upon delta is bracket 3s minus 2s. So you will get s upon delta into s, so you will get the value s square by delta. Okay, that was your question. Now the next question is, in a triangle ABC, in a triangle ABC, prove that prove that 4 times of R1 R2 plus R2 R3 plus R3 R1 is equal to A plus B plus C whole square. So student, in normal class, I have tell you the value of R, R1, R2, R3. The value of R1 is delta upon S minus A. The value of R2 is delta upon S minus B. And the value of R3 is delta upon S minus C. In normal classes, I have discussed these values with you. Okay, and I have also provided the proof of that question. So this was your only revision batch. So you have to remember these values to solve the question. Okay, their proof will not come in the papers. Their values will come in the paper. Okay, so we know that R1 equal to delta upon S minus A, R2 equal to delta upon S minus B, and R3 equal to delta upon S minus C. Now put one by one these value in the RH in LHS. So in taking LHS, firstly taking LHS. So LHS is 4 times of R1 R2 plus R2 R3 plus R3 R1. Now put the value one by one. 4 times of the value of R1 was delta upon S minus A. The value of R2 is delta upon S minus B. The value of R2 is delta upon S minus B. And the value of R3 is delta upon S minus C. Now in third term, the value of R3 is delta upon S minus C. And the value of R1 is delta upon S minus A. Now take delta square, delta into delta, delta is into delta into delta. So take delta square common. So you will get the value 1 upon S minus A into S minus B plus 1 upon S minus B into S minus C plus 1 upon S minus C into S minus C. So that are the values of LHS. The 4 delta square upon 1 upon S minus A, S minus B plus 1 upon S minus B, S minus C plus 1 upon S minus C, S minus A. Now in next page, I am writing once again this part. So 4 delta square is equal to the 4 delta square into 1 upon S minus A into S minus B plus 1 upon S minus B into S minus C plus 1 upon S minus C into S minus A. Now if you take S minus A, S minus B, S minus C LCM, so taking S minus A, S minus B, S minus C LCM, S minus A, S minus B, S minus C. Now firstly divide S minus A and S minus B with S minus A, S minus B, S minus C. So you will get S minus C in numerator. Now next divide this term by this term. So you will get S minus A. Now again dividing this term with the denominator of with S minus C and S minus C. So you will get S minus B as common. So 4 delta square. Now if you added all this, so you will get S plus S plus S 3S minus A plus B plus C upon S minus A, S minus B, S minus C. So what is the value of A plus B plus C? The value of A plus B plus C is 2S. So you will get the value 4 delta square 4 times of delta square 3S minus 2S upon S minus A, S minus B, S minus C. So 3s minus 2s is s. So 4 delta square s upon s minus a, s minus b, s minus c. And we know that the delta is equal to, since delta is equal to under root of s, s minus a, s minus b, s minus c. So that was the value of delta. So if you put delta is equal to under root s, s minus a, s minus b, s minus c. So you will get as 4 times of s into s minus a, s minus b, s minus c, and uh, 3s minus 2s is 2s. So into s upon s minus a, s minus b, s minus c. So that term will be cancelled. So 4s into s will become 4s square, which is equal to 2s whole square. And the value of 2s is a plus b plus c whole square. So which is equal to your RHS. Now your next important question is, previous year question is, in a triangle ABC, in a triangle ABC, if 1 upon A plus C plus 1 upon B plus C is equal to 3 upon A plus B plus C, then show that C equal to 60 degree. Then show that C equal to 60 degree. I think this question I have solved in the and previous class. So once again, I am solving this question. Those students which are not present in that class can see in the class. Okay. So 1 upon A plus C. This question is repeated 3 times in your previous year question. So that was very important for exam point of view. So 1 upon A plus C plus 1 upon B plus C is equal to 3 upon A plus B plus C. Now take common A plus C into B plus C. Now B plus C plus A plus C upon 3 upon A plus B plus C. Now you can write this as A plus B plus C plus C. A plus B plus C plus C upon A plus C into B plus C is equal to 3 upon A plus B plus C. Now cross multiply with them. So you will get A plus B plus C whole square plus C times of A plus B plus C into 3 times of uh, A plus C into B plus C. Okay. So you will get a value A plus B plus C whole square plus C times of A plus B plus C into 3 times of if you multiply, so you will get A square plus AC plus BC plus C square. Now, if you open the formula, I'm doing it in next part. Next, A plus B plus C whole square plus C times of A plus B plus C plus 3 times of A square plus AC plus BC plus C square, A square plus AC plus BC plus C square. So you will get A square plus B square plus C square plus 2AB plus 2BC plus 2CA will be the value of first one. Now if you multiply with C, so you will get CA plus CB plus C square is equal to 3A square plus 3AC plus 3BC plus 3C square. Okay. Now if you see in the left hand side, so A square plus B square plus 2C square plus CA plus CA. So you will get 3AC, CB plus BC. So you will get 3BC plus 2AB is equal to 3A square plus 3C square plus 3AC plus 3BC. Now cancel that part. 3AC, 3BC will be cancelled. And if A square, 3 times of A square, just a minute, 3 times of AB, sorry, here AB will come out. AB, AC, then BC plus C square. So here, by mistake, I have written A square. So that was AB, not A square. Okay. So correct this mistake. This was AB, AB, AB. Okay. If that AB will come here and that C square will, if that AB come to left hand side and that C square come to right hand side, so you will get A square plus B square minus C square is equal to 3AB minus 2AB. Now 3AB minus 2AB is equal to AB and A square plus B square minus C square. If AB come in denominator, so you will get A square plus B square minus C square upon AB is equal to 1. Now multiply both side by 1 upon multiply both side by 1 upon 2. So you will get A square plus B square minus C square by 2AB is equal to 1 upon 2. And that was the value of cos C. And if cos C is 1 upon 2, then C is equal to 60 degree. Okay, that was your question. Now next question is, in a triangle ABC, show that 1 upon R square plus 1 upon R1 square plus 1 upon R2 square plus 1 upon R3 square is equal to A square plus B square plus C square upon delta square. So we know that R is equal to delta upon S. We know the formula R is equal to delta upon S, R1 equal to delta upon S minus A, R2 equal to delta upon S minus B, and R3 equal to delta upon S minus C. On putting all these values in LHS, so taking LHS, firstly I am taking LHS. Now putting all the values in LHS, so you will get delta square, S square upon delta square plus S minus A whole square upon delta square plus S minus B whole square upon delta square plus S minus C whole square upon delta square. Now I'm taking 1 upon delta square common. So I will get S square plus S minus A whole square plus S minus B whole square plus S minus C whole square. So 1 upon delta square is equal to S square plus S minus A whole square is S square plus A square minus 2AS plus S minus B whole square is S square plus B square minus 2BS, and S minus C whole square is S square plus C square minus 2CS. Now S square, S square, S square, S square, which will become 4S square. So 4 times of S square plus A square plus B square plus C square. A square plus B square plus C square. A square plus B square plus C square. Now which was left? Minus 2S I take common. So A plus B plus C. And we know that 2S is equal to A plus B plus C. So in place of 2S, I can write A plus B plus C. So 1 upon delta square is equal to 4S square plus A square plus B square plus C square minus 2S into 2S will become 4S square. So that term will be cancelled. So you will get the value A square plus B square plus C square upon delta square, which was its RHS. Hence proven. Now the next question is, prove that prove that 1 plus cos of a minus b into cos c upon 1 plus cos a minus c into cos b is equal to a square plus b square, a square plus b square upon a square plus c square. Now I'm taking the LHS, taking LHS. So what is the value of LHS? 1 plus cos of a minus b times of cos c, and then upon 1 plus cos a minus c cos b. So 1 plus cos of a minus b, and cos c can be written as 180 minus theta. So cos c, because in a triangle a plus b plus c equal to 180 degree, so I can write c as 180 minus a plus b. Okay, and similarly b as 180 minus a plus a, 180 minus a plus c. So c is equal to 180 minus a plus b, cos is 180 minus a plus b, and in by 1 plus cos a minus c cos 180 minus a plus c. So cos 180 minus theta is cos theta. So 1 plus cos a minus b, 1 plus cos a minus b times of minus of cos a plus b, because we know that cos 180 minus theta is equal to minus of cos theta. It come in the second quadrant, na? And in second quadrant only sine and cosec will be positive, rather all sign will be negative. And in the by we will get 1 plus cos a minus c minus of 1 plus minus of cos a plus c. Now if minus sign come outside, so you will get 1 minus cos of a minus b, and cos of a plus b, and here 1 minus cos of a minus c into cos of a plus c. Okay, we know that the formula of cos a plus b into cos a minus b, cos a plus b into cos a minus b is equal to cos square a minus cos square, so sorry, cos square a minus sine square b. So in place I can write 1 minus of cos square a minus sine square of b, and here I can write 1 minus of cos a minus c as cos square of a plus sine square, sorry, plus sine square of b, plus sine square. Just a minute. Cos square a minus sine square a plus sine square b upon sine square a plus Sine square c. And the cosine sine rule tell us that according to sine rule that a upon sine a is equal to b upon sine b is equal to c upon sine c is equal to 2r. So a is equal to 2r of sine a, b is equal to 2r of sine b, c is equal to 2r of sine c. So in place of sine a, we have given sine a now. So sine a equal to 2r upon a, sine a equal to 2r upon a. Similarly, sine b equal to 2r upon b, and similarly sine c equal to 2r upon c. Sine c equal to 2r upon c. Now put one by one the value. Sine a is 2r upon a whole square plus sine b is 2r upon b whole square plus sine a is 2r upon a whole square. A upon 2r, I think. Just a minute. A upon 2r. Sine a is equal to a upon 2r. Similarly, sine b is equal to b upon 2r, and sine c is equal to c upon 2r. Now put one by one these values here. So you will get a upon 2r whole square plus b upon 2r whole square, and in by a upon 2r whole square plus c upon 2r whole square. Now all 2r square term will be cancelled because you will get in the numerator a square plus b square upon 4r square, and in denominator you will get a square plus c square upon 4r square. Now the 4r square term will be cancelled, so you will get the value a square plus b square upon a square plus c square, which is equal to your RHS. Okay, that was the solution of your question. Now next question is, now next previous year question is, in a triangle ABC, if A is equal to 13, B is equal to 14, C is equal to 15, then show that R equal to 65 by 8 and small r equal to 4, R1 equal to 21 by 2, and R3 equal to 14. For all that question, firstly we have to find the value of S. So we know that S is equal to A plus B plus C by 2. Here A is 13, B is 14, C is 15 by 2. So 13, 3, 4, 1, 5, 12, 2, 1 balance 42 by 2. You will get the value of S as 21. Now the value of delta means area. Area is equal to under root of S minus A, S minus B, S minus C. Equal to 21, 21 minus 13, 21 minus 14, and 21 minus 15. So you will get 21 minus 13 as 8. So under root 21 times of 8 into 7 into 6. So if you break this in a part, so you will get 3 into 7 into 2 into 2 into 2 into 7 into 2 into 3. Now see the common, 3 into 3 will common. So you will get the 7, 3, 2, 2. 7 into 3 into 2 into 2. That means 84. So the value of delta will be 84. Now the value of R is ABC upon 4 delta. ABC upon 4 times of delta. So A is 13, B is 14, C is 15 upon 4 times of delta. Delta is 84. So 14 14 14 6 are 84. Now 3 5 are 15 and 3 2 just 6. So 13 5 just 65 and 4 2 are 8. So firstly we have proof R is equal to 65 by 8. Now next is R equal to 4. We know that R equal to delta by S. Delta is 84 and S is 21. 21 4 is 84. Now next we have proof R is equal to delta by SS 84. Our next part is of R1. So R1 equal to 21 by 2. How we can prove? R1 is known as delta upon S minus A. So delta is 84 and the value of is 21 minus 13. So 21 minus 13 is 8. So 84 upon 8 is equal to 21 by 2. Now next is your R2. R2 equal to delta upon S minus B. So the value of delta will be 84. The value of it will be 21 minus 14. So 84 upon 7. So 7 is 7, 7 to the 14. So 7 to the 14. Now the last, the value of R3 will be delta upon S minus C. So delta is 84, S is 21, and the value of C is 14. Sorry, 15. 84 upon 6. So that was equal to 12. So all we have proof the value of R1, R2, R3. Now next is now next question is If R into R2 is equal to R3 into R1 point B, we know that R is equal to delta upon S into R2 is delta upon S minus B, and R3 is delta upon S minus C, and R4 is delta upon S minus A. So if you cancel, so you will get S minus C into S minus A is equal to S of S minus B. So if you take this in the common, so you will get S minus A, S minus C upon S, S minus B is equal to 1. So that was the value of 10 square b by 2, because 10 b by 2 is under root s minus a, s minus c upon s, s minus b. So 10 square b by 2 is equal to 1. So 10 b by 2 equal to 1. So b by 2 equal to pi by 4. So b equal to pi by 2. That means it is at right angle. Okay, that was your question. Now next is find the value of find the value of r into r1 into r2 into r3. Okay, so we know that R is equal to delta upon S, R1 equal to delta upon S minus A, R2 is equal to delta upon S minus B, and R3 is delta upon S minus C. Now if you take common, so delta ki power 4 upon S, S minus A, S minus B, S minus C. So that was the value of delta square. So delta 4 upon delta square is equal to delta square. That was the value of delta square. Now next question is your previous year question. If area of triangle ABC is 84, if area of triangle ABC is 84 square unit, its circumference is 24, its circumference is 24 units, then find its in radius. Then find its in radius. In radius. So student, we have discussed in the previous slide that the formula of in radius is R is equal to delta upon S. And in the question, the area was given. That means delta is equal to 84 and his circumference. Circumference is generally your perimeter. So what is the perimeter? 2S is equal to 24. So the value of S will be here 12. Okay. So put the value of delta and S here. So you will get delta 84 and S is equal to 12. So you will get the value of in radius is equal to 7. Okay. So that are your questions. There are some important questions which will come in your previous year. So I have discussed all the previous year of that chapter. Firstly, I have discussed all the formulas that are important for your exam point of view. Then I discuss all the questions in all the questions that are come in your previous years. Okay, so check again and again these questions. And one of the important question that is repeated 2 or 3 times in your exam is that just a minute. That one is your the important question of that chapter. This question repeated 2 or 3 times. Sorry, more than 3 times in your paper. Okay, so mark this question as important. Okay, so that's all for today. In next class I will discuss the remaining chapter of mathematics. In mathematics I have discussed firstly a vector chapter, then trigonometric equation, the general solution of trigonometric equation, inverse trigonometric functions, and properties of triangle. Okay, and hyperbolic functions. So we have discussed 6 part in the mathematics. Now in the next part I will discuss another chapter of mathematics. Okay, that's all for today. Thank you everyone.